Hey there, tech explorers! Welcome to a journey through the fascinating world of networks and IP addresses. Today, we're diving deep into the digital realm to uncover the secrets that keep our online lives running smoothly. Imagine sending a letter without an address. It would be complete chaos. The mail would never reach its destination, and the same goes for data on the internet. That's where IP addresses come in. They act like digital addresses, ensuring that data packets find their way to the right device. And then there's subnetting, the magic that organizes these addresses into manageable chunks. Subnetting takes things a step further, making networks faster, more secure, and way more efficient. It divides a large network into smaller, more manageable subnetworks, each with its own unique address range. By the end of this adventure, you'll be navigating the network like a pro. You'll understand how IP addresses and subnetting keep our digital world connected and running smoothly. Let's get started. Let's start with the basics. What exactly is an IP address? Think of it as your home address but for devices on a network. Just like your home address tells the postal service where to deliver your mail, an IP address tells other devices on the network where to send data. Each device on a network needs a unique IP address to communicate. It's a series of numbers like 192.168.1.100 that acts as a unique identifier. Without it, your computer would be lost in the vast digital landscape, unable to connect with the online world. Now, you might have heard whispers of IPv4 and IPv6. These are like two generations of IP addresses. IPv4 is the older system using a series of 4 numbers. It's like the original telephone system. It worked great for a while, but then we ran out of numbers. Enter IPv6, the cool new kid on the block. It uses a more complex system with 8 groups of characters, providing an almost unimaginable number of addresses. That's like switching from handwritten letters to email, way more capacity and efficiency. Why the change? Well, with more devices connecting to the internet than ever before, smartphones, tablets, even your fridge, we simply needed more addresses. IPv6 ensures we won't run out anytime soon, paving the way for a future of interconnected everything. Now imagine a bustling city with millions of homes. Delivering mail would be a nightmare without some organization, right? That's where subnetting comes in. It's like dividing a city into neighborhoods, each with its own postal code. In networking terms, subnetting splits a large network into smaller, more manageable subnetworks. Instead of having one giant network, you have smaller interconnected ones. This makes everything smoother and more efficient, preventing bottlenecks and keeping everyone happy. Section 5. Unmasking the mystery subnet masks explained. Okay, so how do we actually create these subnetworks? This is where subnet masks come in. They're like the secret code that tells devices which subnet they belong to. Remember how your IP address has 2 parts, the network portion and the host portion? The subnet mask works alongside the IP address, telling the network which part is the network address and which part identifies the specific device. It looks like an IP address, but it's not. It uses a series of 1s and 0s or their decimal equivalents to define the network and host portions of the IP address. The 1s represent the network portion, while the 0s represent the host portion. Section 6. Subnet masks in action. Examples and impact. Let's look at an example. Subnet masks are crucial in defining the boundaries of a network. They help in segmenting a larger network into smaller, more manageable subnetworks, which can improve efficiency and security. A common subnet mask is 255.255.255.0. This is often used in small to medium-sized networks. This means the first 3 parts of the IP address identify the network, while the last part identifies the device. Essentially, it tells the network which part of the IP address is the network portion and which part is the host portion. Changing the subnet mask changes how many devices you can have on a network. For instance, a subnet mask of 255.255.255.0 allows for up to 254 devices on a single network. A smaller subnet mask like 255.255.0.0 means a larger network with more devices but can lead to slower speeds. This is because more devices share the same network resources, which can cause congestion and reduce performance. A larger subnet mask, like 255.255.255.240, means a smaller network but potentially faster speeds. This is because fewer devices are competing for the same network resources, leading to less congestion and better performance. Choosing the right subnet mask is like choosing the right size pizza for your party. It depends on how many people you need to feed. If you have a large group, you need a bigger pizza. Similarly, if you have a large network, you need a subnet mask that can accommodate more devices. You want to strike a balance between network size and performance. Too many devices on a network can slow it down, but too few can mean underutilizing your resources. By carefully choosing your subnet mask, you can optimize your network for both size and speed, ensuring efficient and effective communication across all devices. Section 8. Keep exploring the network. That's IP addressing and subnetting in a nutshell. We've covered the basics, from what an IP address is to the power of subnetting. Remember, it's all about creating a well-organized and efficient network for all your devices to thrive. But this is just the beginning. The world of networking is vast and ever-evolving. There's always something new to learn, from advanced subnetting techniques to the intricacies of network protocols. So keep experimenting, keep exploring, and keep that curiosity burning. Let me know in the comments if you need video on a special topic, and if you enjoyed this video and want to see more content like this, make sure to hit that like button and don't forget to subscribe and ring the bell so you won't miss any of our future videos.